Hello, my name is James Letchinger, and this is a presentation of my stationary robot for EEC 255. So I made a sorting robot with a robotic arm with 3 degrees of freedom, and there's 4 different sorting areas. The first area is the receiving area. That's where bins will be placed for the robot to sort. The second area is greenery. That's for green bins. The third area is bottles, that's for blue bins, and the fourth area is for paper, and that's for brown bins. So I'll place a bin into receiving, and then it will move it to the appropriate area. So I'll start with brown. Okay, and it moves it into the paper area. Next I'll do green. I'll move it to the greenery area, and then I'll do blue for bottles. I'll place it into the bottles area. And you can see that the order doesn't matter, so let's say I'll do green again. It'll still detect that it's greenery and place it into the greenery area. Just like that. Okay, so I'll show off the structure of my robot now. So everything is powered off of 5 volts. So this is just a 5-volt battery. And then I have 2 power connections, one for the servos, and then the other is for the processor, which is a Raspberry Pi 4. So the power connector for the servos is just a USB cable that I cut open, and I took the 5-volt and the ground wires, and then I soldered them onto a proto board with 2 capacitors to filter noise. And then the output from that is going to be 4 5-volt and 4 ground wires, along with an extra ground wire that will connect to the Raspberry Pi to make a common ground. From the Raspberry Pi end, it will have 4 connections to GPIO. So these are going to be the PWM controls for the servos. Those PWM control wires, along with the 5-volt and ground wires, are going to go through 6 toroids. I wrap the wires around the toroids. These are ferrite toroids in order to make an inductance. So in case there's a power drop, the inductance will smooth out the power drop, and it will reduce noise and make the robot less jittery. The robot arm and the base are fully 3D printed. I designed the base and the arm, and my partner Ege designed the gripper. The robot has 3 degrees of freedom. The first degree of freedom is the base, which can rotate, and the other 2 degrees of freedom are along the same axis along the robot arm, and that will allow the robot to both reach out and move the arm up and down. And then the gripper has a single smaller servo to adjust the angle of the gripper. So yeah, that's my robot. Thanks for watching. Okay, so now I'm going to show how my robot was programmed. So what you see here is Raspbian. This is the operating system that my robot is running on, and it's running off the Raspberry Pi 4 processor. So when you plug in my robot, you don't have to interact with the operating system because it just runs this code on startup. So I just insert this line into an ETC file, and every time you turn on the robot, it will just run robotlight.py. So we'll go into the Python IDE that I used to program the robot. So this is robotlight. So this is what ran when I demoed the robot. But right now I'm actually going to show robot_dev. This has a little bit more transparency and a few extra features that help me program the robot. So if we just run this, you'll see there's 2 modes. So auto mode is what I showed off in the demo. And now you can see there's a real-time image of the robot's camera, and there's a white rectangle in the middle. That's the region of interest. So it will only pull colors from that region. And you can see it also did auto white balancing. So I created an auto white balancer that looks at the white piece of paper and adjusts the RGB values until they're almost equal. So you can see here it started off a little bit more different, and then here they're a little bit closer. There's some variation, but Once I get it close enough, I'll end the white balance script. Okay, so now the robot's primed, so if I just put a bin in front of it, it'll detect it, and you can see the code running here. These are the calls to the servos, and the servos move the robot arm. So we can see each bin has its own unique robot code. That's blue, and then here's green. And you notice sometimes it's moving just one servo, and other times it's moving multiple servos at the same time. And the reason for that is that it actually requires two servos to move the arm straight up or straight down. For example, right here, in order to move the robot arm straight up, you actually have to move the arm 1 and the arm 2 servos at the same time. Okay, so now I'm going to restart my code, and I'm going to go into manual mode. So manual mode has a series of functions that I've written, and these functions allow you to move the servos and do some other things. So I'll start off with the list command. The list command gives you all the angular positions of the servos. So the base is at 0 degrees, the first arm's at -20 degrees, and now we can change these values. So if I type in base and then say 45, this will change the base to be at 45 degrees. And then I can also go the other direction. So I could say -45 degrees. It'll go past 0 back to -45, and if I type reset, it'll go back to 0. It'll reset the positions of all the servos to their default state. Alright, so I'm going to show off the elevate function now. So this will actually move multiple servos at the same time. So when I type -10, it's going to move both the arm 1 and the arm 2 servos by 10 degrees, but you'll notice the arm 1 servo is increasing from -20 to -10, while the arm 2 servo is decreasing from 70 to 60. If I run the skim function, instead of bringing the servo arm straight up and straight down, this is along the horizontal plane. So if I move this, you can see that the servos are actually moving together now. They both are increasing. This one from -10 to 0, and the other one from 60 to 70. Okay, so I'm going to stop my code, and then I'll just run through it real quick to show you how I programmed all these functions. So here are the constants, or some of the constants, there's more later, but these show all the limits of the servos. So you can see that arm 1 can only go between -50 degrees and 30 degrees. And these are hard-coded limits. The servo can't go beyond this. And the reason for that is that if it does go beyond this, it could break the components, and then I'd have to reprint them again. And that would take a while. So I was pretty careful in these limits. Okay, so here's where I used GPIO0 to program my servos, which is a very nice library. And here's where I initialize the servos using those library functions. Okay, so I kind of have a hierarchy of functions. So here's the lowest level of my function hierarchy. It's servo pan, and what this does is it converts positions of the servos and turns it into more of a smooth linear motion. So you can see for every single servo I have a for loop, and what this does is it converts a difference between angles into kind of a linear, smooth progression. So for each I in the loop, it only increments the angle by a single degree. And if I didn't do this, the servos would move very fast and be very jerky and inaccurate. Alright, so now here's the servo angle function. So this is a level higher on the abstraction hierarchy. So this just makes sure that the limits are observed. So if it goes past the limits, the angle of the servos is just set to the absolute maximum or the absolute minimum. Okay, and then you can also see I had to increment or decrement some of the variables just by 1, and this was just due to Python's on the for loops in Python. It's kind of hard to explain, but basically, like if I didn't have these +1 or -1, if I told it to move 10 degrees, it would only move 9, and so I had to increase this by 1 so it actually moved 10 degrees. Okay, so here's like the highest level of the abstraction. So these functions are to move the bins to the right place. So for example, if it sees greenery, it will run this greenery command. And this basically says, move the base to this position, move the arm to this position, move the arm down, sort of de-elevate it, and then close the gripper. Actually, this is opening the gripper, and then reset back to the standard position. So there's one of these for all the different bins. And then here's my auto white balancing script. You'll notice there's actually an offset for blue. I don't want blue to be the same value as others, and the reason for this is that it's very hard to detect the color brown. Often it will think it's blue, and so I have this blue offset that I take away from the white balance values, and that will make my image slightly less blue, and so I won't get false positives on blue values. Otherwise, sometimes when I put in brown, it would think it's blue. Or actually, what would happen is that it wouldn't think any color is detected at all. And there's also thresholds. So if like a color is just slightly green, it's not good enough. It actually has to be above the threshold in order to count as green. But that's on the auto white balance script. Okay, go further down. Okay, so here's kind of the user interface for the manual mode. So here's where I say like, here's the list of commands, right? And then this is where I print out the values so you can see them on the screen. Okay, here's auto mode. So I have to initialize the camera, and so I manually set the ISO and shutter speed so that they don't change. I want them to stay constant so that the robot's more reliable. Okay, here's the kind of like the graphics that you saw on the screen earlier. I highlighted the region of interest so that it's kind of more clear what the robot's paying attention to. Okay, and then here's like where the real magic of the code is. Here's where it detects color. So it takes a photo of the frame. It takes a photo of the backdrop every 1 second, and it stores it into a 3D array. The first dimension is the x-axis, the second dimension is the y-axis, and the third dimension is color. And that third axis is either R, G, or B. Or sorry, the third dimension can either be R, G, or B. So I need to get averages for each of the colors, and so for that third dimension, I just set it to a single value. So here I'm only looking at values of red, and then I only look at the X and Y's that are within the region of interest, right? And then here for green, so G is second, or so since we count from 0, it's the first one, and then blue is the second value. Okay, so going farther down, here's where I detect the colors, and then here's these thresholds I was talking about earlier. So if a color isn't green enough, it won't be greater than the threshold, and it won't count as green. So that's how I prevent false positives from happening. Yeah, and so if it doesn't meet any of these values, then it's simply treated as no color. So yeah, that's my my code. So thanks for watching.